This video is about 8-2 special right triangles. Alright, there's two types of special right triangles. Your first one is your 45-45-90 triangle. It looks like this. You have a right triangle and then the two base angles are 45 degrees. This is also called an isosceles right triangle. Alright, anytime you have an isosceles right triangle, it is a 45-45-90 right triangle. Alright, your second type is your 30-60-90 triangle. Looks like this. You have a right triangle, one of the angles is 30, one of the angles is 60 degrees. Now, you might ask me, well, what's so special about these that they have their own section in the book? Alright, well, here's what's special about them. Let's start with the 45-45-90 triangle. Alright, the legs of a 45-45-90 triangle are the exact same length. So in this case, they're both S. Now the hypotenuse is the leg length times the square root of 2. Alright, so they're in the ratio, because we just got done with ratios, so they're in the ratio of S times, and then S times the square root of 2. So if you have a 45-45-90 triangle and you know one side length, you can find all three side lengths just from knowing that one, and you do not have to use the Pythagorean theorem. You might say, well, how can we do that? Well, say we knew what this leg was. Say this leg was 5. Alright, well, to get the hypotenuse, which of course is the side opposite the 90, we just take a leg multiplied by the square root of 2. So our leg is 5 times the square root of 2. That means our hypotenuse here would be 5 times the square root of 2. Now, what happens if we're given a leg, or if we're only given the hypotenuse and we want to find a leg? Well, hypotenuse divided by the square root of 2 gives you the length of the legs of your triangle. Alright? And don't forget, you need to rationalize this, because you can't have a square root or a radical in the denominator. Alright? But that's basically what you do. Hypotenuse equals a leg times the square root of 2. A leg equals the hypotenuse divided by the square root of 2. Let's look at an example. Or two examples, rather. So let's look at this top one here. Well, 2 to the square root of 2. The first thing we need to do, we know it's a 45-45-90 triangle because I have the angles labeled. First thing we need to do is that 2 square root of 2, is that a leg or the hypotenuse? Alright, well, it is a leg, and this x is the hypotenuse. So we know that the hypotenuse equals a leg times the square root of 2. So our hypotenuse is x. We know x equals 2 square root of 2 times the square root of 2. Well, 2 times the square root of 2 times the square root of 2, that gives us 2, and then the square root of 2's multiplied together, the square roots cancel out, leaving just what's underneath it. So this would be 2 times 2, which is 4. Alright? So in this case, our hypotenuse would be 4, because 2 times the square root of 2 times the square root of 2 gives us 4. Alright? Now let's look here. Here we have another example. We know this is a 45-45-90 triangle because these two angles are marked congruent. Since these two angles are marked congruent, we know they have to be the same thing. Since this is a right triangle, we know they have to be 45, making this a 45-45-90 special right triangle. So 6 is our hypotenuse. Well, and we need to find a leg. Well, we know a leg equals the hypotenuse divided by the square root of 2. So y is going to equal 6 divided by the square root of 2. We have to rationalize our denominator. So we have to multiply the top and the bottom by the radical in the bottom, and only the radical in the bottom. So 6 times this equals 6 times the square root of 2. Square root of 2 times the square root of 2 is 2. Now if you notice, the 6 and 2 will reduce. This will go to a 1, this will go to a 3. So y equals 3 times the square root of 2. Alright, so hypotenuse is a leg times the square root of 2. We were given a leg, so we found the length of the hypotenuse. Here, a leg is the hypotenuse divided by the square root of 2. We had the hypotenuse, so we use that to find the leg. Don't forget about rationalizing your denominator. You need to make sure you rationalize your denominator. Okay? Now, let's look at the 30, 60, 90. Here's your 30, 60, 90. We have 30-degree angle here, 60-degree angle here, so we know it's 30, 60, 90. Now, if you remember back, across from your smallest side is your smallest angle, correct? So here we have our smallest angle, which means this will be our smallest side, and that is length S. Across from your largest angle is your largest side. So across from 90 is our largest side. That is 2 times S. And then the third side, which is across from the 60-degree angle, is S times the square root of 3. Alright, so your hypotenuse is your short leg times 2, and your long leg is your short leg times the square root of 3. And we can also manipulate this formula to figure out these two if we're only given the long leg. Okay? First thing we'd want to do, if we're only given the long leg, we'd have to figure out the short leg, of course. And the short leg would equal short leg would divide both sides by the square root of 3, so the short leg would be the long leg divided by the square root of 3. Once you have the short leg, you can use this formula to get your hypotenuse. Alright? But if you notice, everything comes back to that short leg. All three of these formulas has the short leg in it. So if you're not given the short leg, the first thing you need to do is find the short leg. Alright? The short leg also equals half of the hypotenuse. Okay? Short leg also equals the hypotenuse divided by 2. Alright? Both of these formulas will give you the short leg. Hypotenuse divided by 2 or the long leg divided by the square root of 3. Let's work a problem. Here is a triangle. If you notice, all three angles are marked congruent, so that means this is an equilateral triangle. Now, we want to find the height of this triangle. How are we going to do this? Well, we know that when we drop this down, this altitude down in an equilateral triangle, we know that it bisects this top angle. So, we know this is a 60-degree angle because it's equilateral. We know this is 90. We know this is 30 degrees. All right. So now, if you remember, our ratio is S to the square root of 3, and then 2S. Remember, S is your shortest side. It's across from your smallest angle. So this is S. All right. Across from the 60 is S times the square root of 3. And then your hypotenuse is 2S. Now, S, you can look at it as stands for short leg. All right. So we know that our hypotenuse equals 2S, or 2 times our short leg. And we know from this picture our hypotenuse is 10. So 10 equals 2S. Divide both sides by 2. So our short leg equals 5. All right, so now we know that this is 5. We could have also got that because we know that this altitude bisects this side, so we know that's 5, and this would be 5, and this would be another 10. But now we're interested in height. Well, if you remember back from the previous board, now that we have the short leg, the long leg, I'm going to say LL, the long leg is simply the short leg times the square root of 3. And since we found the short leg, our long leg is simply 5 times the square root of 3. So, 5 times the square root of 3 is the height of an equilateral triangle with a side length of 10. All right, let's work one more problem. Here we're given a 30, 60, 90 triangle. It's clearly marked. And we need to find x and y. All right. Well, we know x because since this is our 60-degree angle, We know x is the long leg, and the long leg in the ratio is s times the square root of 3. We know y, since it's across from the 30, is the short leg. We know the short leg is just s. And of course, we know this is the hypotenuse because it's across from the 90. So we know that it is 2s in our ratio. All right, so we know that 6 equals 2s. Divide by 2, because the first thing we want to find is the short leg. That's the first thing you want to find if you're not given the short leg. You need to find it first. So in this case, our short leg equals 3. So y in this case equals 3. Now, our long leg is simply our short leg times the square root of 3. So our long leg, which is also x, is s, which is 3, times the square root of 3. Alright? So, your two special triangles, they both have a specific ratio that their sides are in. For the 45, 45, 90, remember it's s, and s times the square root of 2. Alright, I'll go back to it. Alright, it's s, and s times the square root of 2. You need to make sure that you remember that ratio for a 45, 45, 90 triangle. This will save you a lot of work when you're trying to solve 45, 45, 90 triangles for the sides. Because if you have a side length, this is the same as this. This is simply this side times the square root of 2. That's it. All right? And you don't even have to multiply it out. You can leave me 5 times the square root of 2. It's called simplest radical form. Completely acceptable answer. All right? Then you have your 30, 60, 90 triangle, which is in the relationship of s times the square root of 3 and 2s. All right? So if you're given one, again here, if you're given one of the 3 sides, you can simply use one of these four formulas. And remember, here you want to find the short side first, because the short side you can get the other 2. Because remember, short side times the square root of 3, 2 times the short side. All right? So, this has been 8-2, special right triangles. You can watch this video as many times as you need to. Make sure you're ready to work some problems tomorrow, and see you tomorrow.